Welcome. In this podcast, we're going to solve a few more problems involving position, velocity, speed, and acceleration, as well as analyze a graph. All right, so first of all, we're going to find, we already have our position function. All right, so it asks us to find all of these things when t equals 4. All right, so the position at 4 seconds, that would be negative 4 to the 4th plus 11 times 4 cubed. So it's going to be negative 256 plus, that would be, so 4 cubed is 64, and then times 11 is going to give us 704. Right, and if we combine those together, we have 448. And let's call this meters per second. Something moving very fast. So 448 meters is going to be the units for position. Right? So meters and seconds is what we'll use. All right, so now let's find v of t. So first we have to find the first derivative. That would be negative 4t cubed plus 33t squared. Let's evaluate that when t is 4. All right, so that's the same as 4 to the 4th power, so that's a negative 256 again. All right, and then 33 times 16 gives us 528. And then if we combine those, we have 272. Now that would be meters per second, would be the units there. So we have meters is going to be our distance measure, and seconds will be our time measure. I should write them out. All right, so we found position, we found the velocity. Now let's find the let's find the speed. That's so easy. All right, we already use s for position. So now I'll just write speed. So speed is the absolute value of velocity. So that means that the speed when t is 4 is going to be the absolute value of 272, which is still 272 meters per second, right? Speed and velocity are the same when velocity is positive. Now let's find acceleration. So we have to find the equation. All right, so this would be the second derivative. I got carried away here. Second derivative. So we'll take the derivative of velocity, right? Derivative of velocity is acceleration. So that would be negative 12t squared plus 33t, right? And we'll evaluate that when t is 4. So that's negative 12 times 4 squared plus 33 times 4. So that's negative 12 times 16. It's going to give us negative 192. And then 33 times 4, that would be 30 times 4. It's 120 plus another 12. That's going to be 132. So that's going to be negative 60, and that's meters per second squared. All right, now that we've found all those things, let's answer the question, is the particle speeding up or slowing down? And we'll explain. So notice that velocity is positive at t equals 4 seconds, but acceleration is negative. So therefore, the particle is slowing down because the sign of velocity and acceleration are different at t equals 4 seconds. Right? something to explain that if those are going to have different signs at some given time, you've got a positive velocity, you have a negative acceleration, right? There, it's going to be slowing down. Sorry. All right, so the third derivative is called jerk. So jerk is a sudden change in acceleration. So velocity is a change in position, and acceleration is a change in velocity, and jerk is a change in acceleration. And it tends to be very sudden. So jerk is the derivative of acceleration. If a body's position at time t is s of t, then the body's jerk at time t is, it's the derivative, so it's the first derivative of acceleration, it's the second derivative of velocity, and it's the third derivative of position. Jerk is meters per second squared per second. Right? And I suppose, although I usually see meters per second squared per second, but I guess we could say meters per second cubed, couldn't we? Right? So that's jerk. Comes up once in a while. And all you have to do is just take the third derivative of position, and it tells us how the acceleration is changing. So now let's take a look at the table here, and we're going to answer the questions. Now, whenever you have a problem like the graph here, and we're going to answer the questions in the table. Whenever you have a question on a graph, the first thing to do is identify what this is a graph of. Because if you're thinking this is position, you're going to answer one way. But this is not position, this is velocity. Okay, so for velocity, we have here the graph of velocity. That means that the values, or y values, are the velocity of the object, right? It's not its position, it's velocity. All right, so now we're going to evaluate this on these different intervals, and this should be in your notes. So from 0 to a is, and we're going to try to put some reasonings in here. I don't think we can fit it in the table, but maybe we can fit it on the graph. So from 0 to a is the velocity positive or negative. The velocity is negative. All right. Let's put a little reason on here on the graph. So v of t is negative because it is below the graph. Or, excuse me, below the x-axis. I don't know why I said graph. I guess it's the graph of the x-axis. It's below the x-axis. So when the graph of velocity is below the x-axis, it's going to be negative. How about the acceleration? All right, notice that the graph of velocity has a negative slope. All right, so if your velocity has a negative slope, then your acceleration is going to be negative. All right, and so we can put a of t is negative because, I'm going to abbreviate because, you know what? I'm going to quickly run out of space on my little graph here. We're not even going to put it because. We're just going to put the reason. So v of t is less than 0 and is graph below the x-axis. Here a of t is less than 0, and we know that because v of t has negative slope. I'm going to be in trouble when I got to squeeze more things in here. So here the speed, they're not referring to the absolute value of velocity on this graph, just because based on the question here. They're referring to speeding up or slowing down. I'll write that in black. That's why it says increasing or decreasing. All right, so notice they both match. We are speeding up. All right, let's look at the next one from A to B. That's this section here. I'll color code this. All right, so velocity. All right, still negative, right? So the graph is below the x-axis, and that's from 0 to B, right? So still negative. Acceleration, however, now is positive. And we can tell that that here a of t is greater than 0 because b of t has a positive slope. And so we are slowing down. And that makes sense because what's going to happen right here at B, right? The particle, is it a particle? I don't remember what it was. Object, particle. Call it an object, I guess. Object is stopped. At B, right? We have an x-intercept on the velocity curve. Our object is stopped. And we can even put v of t equals 0. That's how we know that. All right, so from B to C. All right, so here, v of t is greater than 0. The graph's above the x-axis. All right, so from B to C, velocity is positive. A of t is also greater than 0 because v of t still has a positive slope. And actually, let's put it over here. So that's going to be from A to C. We had that positive slope, so this is positive. And that means we are speeding up. From C to D. I need another color, purple. All right, so the velocity curve is still above the x-axis, so it is still positive. On the other hand, notice that A of t is going to be less than 0 because v of t has a negative slope. All right, so this is negative. So we are slowing down. Well, the particle is slowing down, the object. We're actually not doing anything. I'm just standing here, actually. So right here, and it makes sense we would slow down because the object is stopped. So object is stopped at B. Object is stopped at D. All right? So I need a new color. Okay, my screen recording box is in the way. Oh, it will be orange. How often do I get to use orange? Oops, my box needs to go away. Well, maybe if I start to write, it will go away. Or maybe it will be right in the way. There. Hopefully it's still orange. All right, so from D to E. All right, so notice that we are below the x-axis. So not only from 0 to B, but also from D to, and then we'll continue that. So here from D to E, we are negative. It is below the x-axis. And acceleration, we still have a negative slope. All right, so we can continue that. Has a negative slope from C to E. All right, so it is negative. Now they match, so we're speeding up. All right, and then I guess I'll just be black. Actually, we'll choose another color, another pretty color. How about pink? Oh, I never get to use pink. There we go. Oh, I wonder if you can read that, though. Oh, I'll have to see. All right, so from E to F, all right, velocity is still negative. Yeah, I don't think you can read that. We'll be black. Velocity is still negative below the x-axis, so from D all the way to F. The acceleration, however, is positive because right here, A of t is going to be greater than 0 because V of t has a positive slope. So they don't match anymore. We are slowing down. And then our graph just stops. What are the values of t at which the speed obtains its local and absolute maximums? And when do the minimum speeds occur? What are they? All right, so let's take a look here. All right, so we are looking for the local and absolute maximum. So what values at which the speed obtains its local and absolute maximums? So now I am guessing that they're referring to not the speeding up or slowing down, they're referring to speed as an absolute value of velocity. Right? And personally, it's hard for me to tell. It's one of two ones, right? So remember, speed is always positive. So the bottom of our graph here, so the part of the graph that's below the x-axis would be reflected above. I think at A. A looks a little bit bigger than C, right? But I would say either A or C. It's hard to tell in the graph. I think maybe A. All right, so at t equals A, or possibly t equals C, the object reaches its greatest speed. And local and absolute. So that would be the absolute. It's an odd way to phrase this question. But it also has some local increases, right? Every time it starts to turn around. So this is a greater value, right, than this, right? So there are some relative, here are relative times we're turning around, right? That's when the speed was the greatest, and then we start to slow down, right? Because it's heading back towards 0. We'll just answer the absolute one. It's not as interesting to me, but there's also some relative maximums at E, right? I think A may be larger than C. When do the minimum speeds occur? What are they? So since it says speed, it's going to be the absolute value, right? So the minimum speed is when it stopped, right? That's clear. The minimum speed is when the object, can I fit this in? I hope you can see this. When the object that's all getting on the board is stopped. And that occurs at t equals b And, I've got to do this. I've got to, somewhere, I can make the board go up. If I can reach it, if I can find it. It's actually below the tray on my board. Oops. And now I can't find it. Here's the mouse. There! Now you can read it. So when the object is stopped at t equals, I couldn't even write anymore. I was so close to the edge of the board. At t equals b. And now, of course, I don't know what the answers are because I can't see the graph. Let's go back up a little bit. And d. At t equals b, and t equals d. All right, that would be because speed doesn't care about direction. So that would be the minimum, is when we are stopped. Right? Right, so I hope that made sense. All right, and so we answered the absolute on the absolute maximum on the speed because that's more interesting. Although we did talk about possibly C, I think it's probably A. Oops, and that's where I wanted to stop. So on the next podcast, I'll show you how that one was solved. All right, thanks for watching. Bye for now.